Hello, this is Rob Hirschfeld. Welcome back to the Crowbar install video series. We are on our third video. We are now at the booting nodes phase. Hopefully you've been able to walk through, if not the bootstrapping, to sort of see a UI tour. That's where I toured all the menu options. And then probably hold off, if you haven't, you can hold off on doing the installs until you're ready to walk through the installs. So at this point, we've already got the system running. I've gone through an initial annealer pass, the admin set up. I've got the node roles converged. And what I'm going to do here is I'm just going to kick off some VMs. So I'm going to clear the screen so you can see what we're doing. So I'm just going to kick off a couple of slaves in this case. Let's see, so that's 3. Go crazy and do 4 slaves. And then from this point, you'll see is that we're basically bringing up a whole bunch of KVM instances. The KVM slave here is really handy for testing. If you checked out the code, I'd automatically build a KVM and attach it. So I'm a fan of being able to do it like that. It saves a lot of time and repetition. And fundamentally, we're just going through this process. Crowbar, by default, when a new system comes up, it owns the DHCP server. That DHCP server is going to direct it to do a Pixie boot. Pixie boot then brings in our sledgehammer, our in-memory image. It does discovery and management and inventory. From there, we then have full control, and we can do RAID and BIOS configurations. We can set the out-of-band management if there is such. It's pretty much a generic pattern. We're currently working on bringing other patterns in. And one of the things to note here is that we don't rely on DHCP to tell us the system's there. We actually allow the system to boot all the way and have the image itself tell us. It's a little bit, it doesn't tell us as quickly that there's a system there, but we found that it was much more generic. Let us not be as tied into the DHCP and trying to sort of backdoor the DHCP server. In this case, servers come in through the front door, the API of Crowbar, and so it's possible to pre-populate information and determine names and IP addresses and all sorts of cool things by pre-populating the database, or allowing you to bring an out-of-band discovery into the system. We've done that before in proof of concept. It's not part of the open source release, but it's something that we talk about all the time. So an example would be the out-of-band management ports come online, they beacon in one way or another to a service. That service then registers in Crowbar using the API. Crowbar could then control the systems out-of-band before they've ever been booted, before their power's even been turned on. So some really interesting ways that you could scale up hardware discovery and config, and it's things we'd be excited to talk to people who want to see that work done. For the community, this mechanism is safe, stable, and universal, and so we felt like it was a good baseline. So from that perspective, we're going to start seeing machines coming in. So these are the nodes that have booted, and it's important to realize what we've done here is we actually have discovered the systems, and before we touch them, we go in and we make corresponding DHCP entries and DNS entries. This is exactly the type of system orchestration that's really important. Some of the changes that we're making in the next release cycle would allow us to notify multiple DHCP servers for next boot information, DNS servers, and really start to be very flexible as a platform. Because every time a system is brought up or changes, these entries are critical control points. Every time a NIC is added or configured in a system, DNS records have to be created. Both IPv4 and IPv6. We support IPv6 natively and then use IPv4 as an overlay. We're really proud of that choice. It's proven to be a good strategy for us. What's going on right now is we're basically pulling all the pieces together. And one of the things that's fun about Crowbar is you can watch the deployment progress. So that now that the system is available, we're actually going to anneal the infrastructure. You can't hear it or see it, but my hard disk is spinning like mad. from the virtual machine settling in my video recording. So you can see Crowbar gives you very clear guidance when it's doing things to different nodes. In this case, you can see exactly what it's doing, where it is in progress. When something fails, you'll get a very clear indication exactly what failed. It's always fun to look at the logs for these steps. So you can see within this individual node, you can see the attributes that are passed back and forth. You can see the work that's been done, the work that's in progress. So very clear idea of what the workflow is for the nodes, and then some very detailed logging so that you can actually see exactly what was done, troubleshoot, do diagnostics. And if something hangs up, you can retry and go back. There's another view for this that's more linear, shows you the things that are actually being done. Crowbar has 10 simultaneous threads. That's configurable, so a larger system, you can boost the thread counts. Shows you what's pending, so you can only do one sequence of work in each node. In multiple nodes you can parallelize, and so this work is waiting to be done after the steps can't start until the steps that are ahead of them in line go, and you can actually look at individual nodes and make the same assessment on a node-by-node basis. So it's really the core of the Crowbar system is this orchestration and annealing that goes in behind the scenes and helps figure out what has to be done in what order. In a physical infrastructure system, this can include out-of-band actions. It can include things in the sledgehammer installs, and then of course in the help and coordinate things in the operating system itself, and then when you're done with all that, hand it off to another infrastructure, Chef, Puppet, Salt, Ansible, once you're above the ready state layer. So now we've been basically moving through the system, configuring the different components. I'm going to go back to the system deployment. And we're literally just letting the system go through its paces and get all of the install steps done. One thing to point out here is that Crowbar does have an understanding of different nodes have different needs. So in this case, you'll notice that we don't install logging client on the admin node. That's where logs go, so we don't have to have the remote client. Same thing with NTP and things like that. In this case, my system's been taxed a little heavily and running slow, so I'm experiencing a timeout. DNS client's usually a pretty reliable step. Since there's an error, I get to show you how we can resolve it. In this case, you can see I've completed these steps. I have these steps remaining. I'm in an error state, and then I have a log. So this DNS client failed, which is what I've looked at. It wasn't able to do it, and it's telling you that we're looking at some 404 object not found. There's some preconditioned problems running with this, and it's basically saying it couldn't get the cookbooks from the Chef server that we use to coordinate cookbook activity. A lot of the native Crowbar's history is in Chef, and a lot of the native capabilities for Crowbar are written in Chef, and we've preserved that. We find it's a very functional domain language for deployment. And one of the things you'll see up here is we have sort of a quick insight into what's going on. I can come back through and very quickly identify status of systems. If I find an error like this, I can retry. What we find is typically network timeouts, usually from internet dependencies, where you have a system dependency on a repo. That repo moved or changed, causes problems. In this case, I retried, and you can see it almost immediately came back as completed. Let's go back to our system deployment, and you can see we're moving back through to complete this work. I'm going to pause, let it flush through. It's actually going to do it a bit faster than I can pause it. So we're completing the last couple steps. The node discovered is actually a no-op role, so it doesn't take any effort to do it. Several of these are no-op, what we call no-ops or milestone roles. They're targets in the workflows, and you build things before or after. They sort of create these stable points that allow you to be very flexible in how the orchestration works. So you can add steps in front of a milestone. You can build chains of logic after a milestone. It's a critical piece in the helping manage and create a scalable workflow. So now that I've gotten the nodes up to this basic step, I get to show off the Readystate Wizard. Readystate Wizard really combines multiple steps that are available in the UI, but we found we did them all the time in a certain sequence, and so we built a wizard that allowed you to do that. And fundamentally, it lets us create a new deployment. Deployments are scoping boundaries, so I can have multiple boundaries where I say these components, like a SQL Server, OpenStack infrastructure, or a Ceph infrastructure, are in a deployment. They have a cross dependency on each other, and you can have parallel deployments that don't sort of bump into each other. They can have similar networks and things like that. Each node belongs to a deployment. So this will put these nodes in this deployment. We have a network mapping. 1G1 is the second 1 gig network. 10G0 would be the first 10 gig network. And there's some very sophisticated logic and ways to build teamed and bonded pairs and VLANs and things like that, all dynamically. I name that range, and then I give it an IP range. Behind the covers, there's also a IPv6 range, and if you wanted to build these using the API or the more detailed networks UI, you'd actually have a lot more control. We found most people want just these basic ones. And then from here, I have these discovered nodes. I can pick different operating systems that if I want to install different operating systems on it. It's sort of fun to make different choices here. It creates a more colorful display as the install goes. So I can pick those different choices. I can run my wizard. Running the wizard doesn't actually start the installs. What it's doing is it's creating the deployment, the network, setting up the nodes, putting them in the state, and then we have a review step. So in this review step, I can come in and see I'm going to build a pilot network. I'm going to get the hardware configured. I'm going to install the operating system, and then this is a milestone role, and hardware configured is a milestone role. If this was physical gear, I would have a lot of RAID and BIOS options and things like that in front of hardware configured, because those things have to be done before I install an OS. And I'll show you, when come back for the pack stack deploy, you'll see us actually add things into the ready state. In this case, when I'm ready for this, I can just hit commit. The commit process tells the annealer that it can start working on these nodes. And so they now can't be edited. They have to go back into the propose mode to be changed. If they're in propose mode, the annealer won't touch them. While they're in this mode, the crowbar will go through and start doing the setup and the install. I can go and add new nodes and add capabilities and things like that. Okay, now so we've been running ourselves to the place where we can run the Readystate Wizard. I have chosen the 3 different operating systems. I'm going to run the wizard. In this case, I've got my different bits and pieces installed. If I wanted to add additional components, I could. So for example, if I picked OpenStack, and I was doing the OpenStack deployment, I'd pick that and add it. Check out the OpenStack video to show that, or the SALT, or any one of our numerous videos where we add additional roles. For now, we're just going to keep things as they are. You can see I've chosen different operating systems here. You can click in and see we've got different operating systems ready to go. When I commit, that turns it over to the annealer, and the annealer is going to start doing its thing, which means that it's going to reboot the different nodes that I have set up, and then it's going to start the install on each one of these nodes. So one thing to note that Crowbar does is first, before it'll do anything else, it recompletes the environment. So it's rebuilt my pilot network, and then it's going to go back through and do the reboot. So at this point, it's doing the hardware configured, it's installing the OS. All this work really sends us back into the system configuration. And it's going to take a while to get back into the pilot. So the real action here is in system. It's very important to understand Crowbar recognizes that it has to reapply a whole bunch of logic and activity against the machines that it built. And so as it's going through, what you'll see is I'm basically going to go through and do 3 OS installs here. And what is happened is Crowbar recognizes, all right, I'm installing new OS. I have to go through and reapply all of this work to reattach this new operating system into my environment. That's a significant step. So I went to Sledgehammer, made Sledgehammer part of my environment, fully integrated logging, DNS, DHCP, all of the things I need to actually treat the machine as a first-class citizen. And then I went back, and when it was time to change the operating system, which you would do not just for a Sledgehammer discovery, but for any OS return, when I install that OS again, I have to reapply all of the system integration components that I had before. That could include burn-in, it could include hooking it to your monitoring system or your inventory system. It could include installing other infrastructure components. And so you'll see here we're actually installing 3 different operating systems. Sense is Sense 7, this is 6.5, and this is Ubuntu. All coming in and doing their appropriate operating system installs. It's going to take a little while. It's literally going to go through. Once those installs are complete, Crowbar is going to reapply all this work and then jump back into the pilot deployment and finish it all the way through down into this. And what I want to do here is I'm going to take a minute, let this install without you having to watch me go through that process, and jump back in to show you some final touches before we end this video. So we're back. We've completed the system deployment here, the pilot deployment, so everything ran through. If I click on one of these machines, you'll see they have different, I can look up their IP addresses. This one's 82, here's the v6, here's the pilot network IP addresses. We had 2 NICs, so we got bound on both. I can also look at that using my network node map, and I can find the different IP addresses that are bound. You'll see the admin is on this network, not on these networks. Let's tour that a little bit. By the way, here's my different machines, my different VMs. In this case, what I really want to do is I want to log into them from my admin node. So here's my admin node. Perfectly normal to get a not converge, which just means a timed out waiting for the production script to run. All right, so now let's play around a little bit. I should be able to ping 192.168.124.81. Good, so that's on that. But I should not be able to get to the 10 network. 10.10.10. We have 11, 10. Right, so I can't reach that machine. So what I really want to do is I want to go into my admin node. And because Crowbar propagates the keys, I can get there. From the admin node, by default, I have to set up as my admin user. If I included my keys, which I can do, if I've created the bridge on my network, 81. I want to do a couple things. First, I want to come back and connect my bridge. So I want to do my bridge control. I want to add an interface to Docker 0. In this case, I'm going to add my hardwired port, E0. You're going to want to have a port that you're not using for anything else. Or if you're using it for anything else, just make sure you don't have IP addresses. And then I want to make sure I add, I have to do it as admin, IP address add. I want to add 192.168.124.2 dev docker 0. And what that'll do is that'll allow me to connect in to that network. So I should be able to ping it now, because I've installed my IP address on it. Oh. It does help if I use the right syntax. To include my subnet address. That will make it possible for me to actually communicate. This bond and connection is in the documentation, so it's useful to do that. But as you can see, even one small mistake in syntax is going to make a difference. No surprise. Let me jump back over to my, so now I should be able to SSH to root. And now I am connecting to that machine. You'll notice it didn't ask me to log in. This is because when we set up Crowbar using I'm using the Docker admin right now. When I do that, it includes my keys. If you include your keys into your Crowbar container in that list, it'll propagate them to the nodes, and you'll be able to log in from anywhere you've put your public keys. We do that as a convenience because when you're dealing with a lot of machines, you need to propagate these keys. So that's pretty handy. So from my machine, I can now get to all those machines. That would be true if not just if I had VMs. If I set up physical nodes from here, my system would now be able to access those hosts. It's really important when you start playing with additional deployment stages and steps, like with Ansible or Chef or Salt or Puppet. Okay, so the next thing, we're back in the admin node over here. I logged in as Crowbar, and now I should be able to duplicate the same steps. SSH root at 192.168.124.81. So I'm already logged in, keys have already been exchanged, everything's good. And now I can ping 10.10.10.10, and I have access to that system. So now that I'm in that, this is a little bit of a tortured path, but now that I've SSH'd into the slave, I have access to both networks. They've both been configured correctly for me. Really important thing, right? Crowbar will set up the networks that you ask it to set up on a dynamic basis. So if you choose different IP ranges, different subnets, different VLANs, different teams, it's going to build those and enable those addresses. It doesn't enable them on places it doesn't need it. So in this case, the admin node doesn't even have access to that network. So now that we've gone through the videos, we've gone through prepare, we've bootstrapped, we've booted our nodes. Now the next steps is for you to choose. We can go into physical, Readystate, or SaltStack.